hell's going on? You got like just full circles and then like a straight bar in the middle. I don't even agree with that either on the ball. If you were to map that, it just doesn't work.
This is how we see the stars.
You
okay?
Witsit.
Barely.
So,
Fuck you.
yes, it is. It's how we see the stars. Now, look, here is the phenomena of anticorpuscular
Crepuscular
rays.
sunlight rays. Sunlight
Buddy,
rays. Get
shut
them
up
off.
with your same
Those sun-
stupid thing. You're just saying the same thing over and over. I could make an AI say your argument at this point. It's not impressive. You mean to go script an AI so I can debate with it and then make it interrupt me every 5 seconds and just keep repeating the same thing? Sun rays aren't the same as star rays. Sun rays aren't the same as star rays, even though my religion said the sun is a star and they are the same, but they're not the same.
But I think you're trying to equate the two in a weird fashion. Like you're trying to say, well, because I mean, from the looks of it, I could be wrong, right? But it seems that you're hinting at that, where you're going to bring in the sun rays and then be like, okay, the stars are doing a very similar thing.
Sources, right? They're both point. They're both point
That's what you
sources.
don't get.
They're doing anything they can to make sure the point doesn't even get made.
Okay, go ahead.
Right.
Go ahead. I mean, I'm not.
They're both point sources, bro. Why are you treating them different?
What's a point source?
A star and the sun.
I don't know. I don't know if the sun is definitionally a point source. I'm pretty sure point source has to be like
I don't know about that last claim.
This will end up taking
that you would have to define. I'm pretty sure. I don't know about that last claim, but I mean, the stars and the sun are like
they're both the same thing. They're
that
stars,
we perceive with light, right?
Duh.
Wait. We get light. What the fuck is wrong with you? We get light. We perceive light. That's how we know stars and the sun exist. There's nothing else. That's all it is.
So we're gonna take it
even in your paradigm, in the globe paradigm, stars are essentially the sun. There is no difference.
They're not
is
the
the light
ray.
from the stars parallel? Yes or no?
Wait, say that again?
Use the
light that
light
comes from the stars
star
parallel?
ray.
Yes or no?
Compare a star ray to a sun ray.
Is the
Compare a
light that comes
star
from the
to a
stars
sun.
parallel? Yes or no?
No.
I mean, I don't really know how that would work for stars.
So you guys need to go back to 3rd grade and learn the globe before you come taunt flat earthers, maybe.
No, stop comparing apples to oranges and claiming you have a win.
Is the light that comes from the stars in your paradigm parallel? Yes or no?
Well, I don't really know what that.
Sun rays and stars.
Well, I don't really know what that means for the stars. I mean, for the sun, that kind of makes sense because you actually have like a size to it. For the stars, I mean, it's just like a.
It means nothing to the stars. Absolutely.
I don't really know
nothing.
if that really makes any sense.
Sure, if you're like 5, it means nothing. So, does the light travel to the Earth from the star parallel? Yes or no?
I mean, I guess technically. I mean, like.
No, there's no I guess technically.
Like, okay, fair. Okay, if I was going to like, I guess take like a photon or whatever the fuck from the star and then to the Earth, and then another one from the star from a different position and then to the Earth. I guess those would be, effectively parallel at that point because the angle.
Yeah.
So I mean, I guess that is a point. I guess.
Okay, cool.
Yeah.
So even in your own paradigm, the sun is a star, and in your own paradigm, the light comes from the stars parallel. So when we examine the actual phenomena we see on the Earth, we have crepuscular and anticorpuscular rays, right?
Okay, but that only works on the ball Earth though, where you have parallel lines. How do you get the parallel?
You're so lost that you have to keep in.
Works in reality, dude.
Okay, so now the sun is setting over here in the west, right? And we see what looks like rays diverging out from the position of the sun, even when we can't see the sun, even when the sun's down seemingly below the horizon, quote unquote.
Okay.
Right? So now when we turn around 180 degrees, we'll see the same thing in the opposite direction from the east. Now the sun is setting in the west, but we'll see it all converge to a singular point, even in the east, okay? So this is just a product of perspective. There is no actual point source where all the rays are diverging from in the east. The sun is in the west. So this is objectively a product of perspective. So what's going to happen if we draw the point on the right and then we draw divergent rays out, then we draw the point on the left and draw divergent rays out, they're going to meet in a center point. Right?
But the stars aren't perspective.
Hey, are they going to meet in the center point?
I guess with what you have here, I mean, I guess that goes without saying.
Well, no, that's not what we have here. It's what we have in reality.
Well, I mean,
and this what happens with sun rays. It doesn't happen with star rays, but yes.
They claim the sun.
See if you guys can answer this question.
But you have diverging lines, though.
This is what we see in reality. So what would happen if I start to spin the rays?
They're not gonna match the stars. That's what will happen.
Okay, see, so what would happen if these begin to spin? What would they look like looking west, and what would they look like looking east?
Yeah, I guess it would mirror it, whatever. But once again, that only works with parallel lines, though. You have to kind of show that this works with something else. Like this doesn't really make sense on the flat Earth.
There'd be a
And the
rotation
sun's
and a
not-
counter
To
rotation.
avoid that point, right? So first of all, you can
You're
have
claiming that
divergent
the
rays.
sun's
Hey,
stars
hey,
are a
hey, let me
reflection of-
enlighten you with something, Arma. You can have divergent rays without parallel rays. In fact, let me break this down for you. In your own paradigm, the rays from the sun aren't actually parallel. They're a light source coming from a sphere that go in all
Okay.
directions. They're divergent light rays in your own paradigm. You call them parallel because you claim that the radius of light from the sun is so big that just a tiny little fraction hits the earth. So for all intents and purposes, we can consider them parallel, even though they are divergent. You
Okay.
understand? Okay, cool. So you obviously don't need parallel rays to see divergent rays. That's ignorant, huh?
No, okay. The rays that we see, the crepuscular rays, right? That isn't caused by the divergent rays, whatever. Like they have to be parallel for this effect to work. If they're diverging, whatever, then you're gonna get a totally different visual.
Not true.
That's incorrect because in
That's
your
not true.
own
Wait,
paradigm, they're
wait,
actually
wait, wait.
divergent.
No, in our paradigm,
let
if
me-
you
let me
actually take a
take
picture of those rays or whatever from above, whatever, I think you've seen those pictures, but those rays are, or the shadows are essentially parallel.
They're actually
They're
not parallel. They're not parallel.
You've
I've
seen them
taken those pictures
diverge.
and shown that they're objectively not parallel.
Yeah, it shows them parallel
know,
from
I've seen
above. But when you get underneath, all of a sudden it starts showing perspective. So she just claimed that
then-
the stars aren't perspective,
No,
but
it
y'all
doesn't even
you
show
control
them as
yourself
parallel
Hold
from
on.
above. Why are you saying that? No,
I've
no.
seen pictures where they're parallel.
Me too. The shadows on the clouds from above. If you
Yeah.
actually draw the lines, they're not parallel.
I mean, I don't know. The ones that I've seen, they
No.
are parallel, but
No, they're not. I've seen the
Oh.
same ones you have. There's only 2 of them that anyone ever shows.
okay.
Okay. So anyway, so if we have this optical effect here, even in your own paradigm, it looks like these rays are diverging to the point of the observer from both directions. So if they started spinning, just answer the question without your follow-up of how you think it's impossible on a flat Earth because you don't understand it. Okay. Do you agree that if this started spinning, then if I look to the west, I'd see one type of rotation, and if I turned around and looked to the east, I'd see the opposite rotation?
I mean, I guess that goes
So
without
why aren't
saying.
they
If you have
reflecting?
this, if you have the structure extend out from the sun, whatever, whether it be a light ray or even like a pole or something, right? Then that goes without saying. You're looking literally like a 180 of that same structure rotating, right? This doesn't apply to the stars because the stars literally are their own thing, right? Unless you're gonna like have them be the same structure or something, and even then, there's still a lot of issues with that. But
You're still lost. Okay, so is there an actual central structure in the center over here in the east?
No, but the thing is, those rays, which would be their own kind of structures, if you want to call them that, right? They would be essentially, what do you call it? Perspective would be essentially have them appear to converge, whatever, right? So what I'm trying to say is those rays that we're seeing converge are still like the same rays from when we do 180 and look at the sun. You can't
Arma,
really
they
do
are
that
where
with
they are,
stars, though.
but they are where they are. We're talking about the rotation of them.
Yeah.
Those rays
you
are
don't even
identical
understand
on
the
both
argument, dude.
sides. Those rays
Sure.
are identical on both sides. The stars are not identical on both sides of the sky.
It's irrelevant. You don't understand
It's
it.
not irrelevant.
It's
literally
pretty relevant.
They can't be.
It's
They
irrelevant
represent
that they
clockwise,
aren't a reflection of the other side of the sky, like this
They
example that
can't be
you're showing me.
reflections. Trouble. They can't be reflections. That's not what we're
Well,
saying.
you're showing me a reflection here that's working on both sides.
No, it's not a
And then you're claiming
reflection.
that's
You don't
what's
even know
happening
what
on
the
the
word
Earth.
reflection
It's
means.
Only the stars
perspective,
aren't a
dear.
reflection.
Okay, fair enough.
Hey,
It's
guys, hold on a
perspective.
second. As a point of moderation, it's really hard. For everyone listening, it's very hard to listen when everyone's talking over each other. Could we try
Fair
just
enough.
giving each other their time to speak and go one at a time so we can hear?
Fair enough.
All right, thank you.
This isn't reflection, it's perspective. Those are fundamentally different.
Okay. Maybe I'll grant you this for now, but there are paradoxes once again that I have brought up, and maybe like towards the end of this, I can bring those up, and maybe we can discuss that because, even with this argument now, if you look actually into it, it doesn't really work at the end of the day. But go on.
That's what you think. So
Alright.
now we see that what you're going to see is that they're going to meet in the middle optically. And they're going to look like they're converging to a singular point in each direction. So if I began to spin this, it would look like all these rays are spinning around a singular point in the east. But of course, there's no source of light in the east, and they're going to look like they're all converging around a singular point. When in reality, they're just spinning. Okay, so just
To every observer, real quick, Austin. To every observer is going to see a rotation and a counter rotation. There's no getting around it.
Correct. This is just objectively how perspective works, and we know this by like actual observation. So here we go. Now we're just going to compare the two ideas. Okay. So
Okay.
right here, we're looking north. We see the stars moving. Now, when we look south, we're going to see them moving the opposite way. When we look in the middle, we're going to see where they're meeting.
But it doesn't really look like that. I mean, it's close, but it doesn't. That's not really close to what they're
Makes
doing.
it works. It works no matter if you make it exactly like it. Good luck trying to like program it out to make it look exactly right on an over the top projection. That doesn't matter. That's completely irrelevant. So we would see it have straight lines in the
I'll
middle.
give you one. I've got one. I'll put it in the back chat for you.
We would see it have straight lines.
Picture it in motion. Sorry, picture it in motion. Trouble. Picture what that's on screen. Picture it all in motion. So in other words, you see at the equator. If you could put that back up, Austin. If you just picture that the middle rotate, moving across the screen basically, and then picture it halfway toward one of the poles moving across the screen, then that's a smaller rotation. And then picture it toward the point. It's just the rotation gets tighter and tighter. Do you at least see what we're trying to explain?
I get what you're trying to explain, but it's not accurate. But yes.
Well, we see with the sun. So you guys have to say that the sun is anomalous, just like Antarctica is anomalous and all that stuff. Okay, so if we look at a depiction of this,
Okay.
first of all, this would be our personal grid of view. If you put it over concentric circles, you see an optical convergence point that's not actually there, right? That's not actually there. Those are just concentric circles, but it'll look like a convergence point through the curved view.
Isn't that a lens?
So you can't deny that. It's just objective. You can say it's not happening on the Earth if you want to, but here you go. You can have concentric circles, and whenever you look in both directions over top of a azimuthal grid of vision or a dome, you're going to get what looks like two different convergence points in both directions.
But that's a lens, though, right?
Do the poles all around in a circle.
Lens, dude, you didn't know?
We got both sides of the poles, and you're only showing one side as if they just meet on a point.
No, I just showed both.
Oh,
sides.
you showed the middle.
Wait, hold on. Wait, what was that about? We said what did you just say?
Around the globe.
We'll get
All right,
there.
so you're proving the globe. All right.
No, what's it? I said that's a lens, and you said what?
For one, our eyes are lenses, and two, we
Okay.
look through the atmosphere that acts as an additional lens.
That's the only spot on the Earth you can see
Yeah.
both rotations. Just so you know,
I mean-
you're only ever going to see one rotation. One pole.
Well, look,
Again,
I'm
here's
under the
also the
celestial equator. So above my head, I see the equator. And to the right is the northern one, and to the left is the southern one. I can see most of the southern one, and I can barely see the top of the
Right, but everywhere else we don't see that. We see like a portion of the rotation. You know, like if you're a little bit further south, you won't see Polaris. You'll see a portion of the northern rotation. It's just when you move that thing around, it pretty much mimics. It's just each individual's perspective.
Well, hold on. Witsit. You say our eyes have lenses in them, whatever, right? Okay, I'll somehow grant you that, right? But the whole lens thing, though.
Grant.
Wait, hold on.
That's the reality.
Okay, whatever. So in that picture, right, where you have these two little circles, whatever, right? Here's the thing, though, right? I don't know if you've ever seen that GIF where the guy is like putting that lens over the stars circle, the circle of stars thing, right? But there's no two centers of rotation, though. It just kind of looks like there's center of rotation. But if you actually follow the stars, they just kind of disappear, and then new stars come in. All right, there's always like and that makes sense too, because if you have a lens over, I don't know, a giant circle of stars, whatever, right, and you're moving across that surface, right, there'll be stars outside of that lens's, whatever. It can't really get
irrelevant. You don't understand it.
Well, the point I'm trying to get at is when we look in the south, right, everyone in the south essentially sees the same stars around the center point or whatever, right? How does that really work with this whole thing? You're sort of bringing this.
Can I say something real quick? So, what we see in reality is two apparent centers of rotation, and basically, what's been demonstrated is that you can create two apparent centers of rotation with a lens.
Exactly the whole point.
Not really. I've seen the videos. They don't really do.
You just
they
always
don't really rotate.
You're not saying
they actually do.
I've seen the video. And they don't really rotate. You can show me, but I'm literally. You can look at it yourself. They don't really rotate around it, and new stars come into the thing. Well, hold on.
Here is how you would see it inside of an azimuthal grid of vision, which is a dome. That's how we actually record the sky. Flatter globe. We went out when we take angles to the sky. We always get a dome every single time. every time.
But you don't get a circle around the pole stars. You get
You're
this
not, we're not,
oval.
you're not understanding.
You've never
So
gotten a perfect circle around the celestial poles.
you just
Why
keep
do you
saying
get this
it's just
oval
so
dome
weird.
shape?
On a globe, though, if unless we're looking that way, we would never get that rotation unless we're looking right at the pole. And you could demonstrate this in reality. You could demonstrate this by setting it up. A guy did it. I'll try and find the video. But unless you're looking right at the pole, you won't get that rotation. You get a bigger rotation. It has to be perspective. It
Hold
can't
on,
be.
Brian.
No,
Brian, it depends on
have
field of
looked
view.
around certain things, and I'm not looking directly at Sigma Octantis. I can be looking way above it, and I'll still
First
get
of all,
the
you've never
circle.
looked at Sigma.
You guys
By
can't
globe.
get
That
on your
doesn't work
model.
in
You'll
reality.
never
If you
get
do
a
that,
perfect round circle over the poles.
But
if you
Brian,
rotate a camera, here's a point.
It's not
If you rotate a camera, unless it's pointing right at one of them poles, you won't get that tight central point. The guy demonstrated it a long
that's not
time ago.
right. That's not
But
right.
in reality, we do see it. So that shows you it's not the camera rotating.
Do you
Brian,
guys understand this illustration?
I mean, as best as I can for this weird, model of yours.
Okay, well, here we go. Now we just put it into a program, okay, and we're going to be on the plane through the middle of that. This is objectively how you would view with curved visual space. It's objective.
But see how much you've spread the poles out? Now the poles are like this long thing instead of this nice round tight thing. You'll never get the celestial poles to work over your flat Earth.
Dude, they're sitting here doing it. So here we
get
put it
into
in a program.
Okay.
Holy
So here it is
shit!
in an actual program.
Oh my
All
god,
right.
Witsit, that's great.
Now watch what we see as they move.
All right.
Oh, don't take away the last branch.
LMFAO.
Don't take away
That's
the
game
last
over.
branch. Don't take
Wait,
away
how
the
is that
last
game over?
branch
How does
the
that? How does
Globals
this
have,
prove
man.
anything? I'm so confused. How is this game over?
How do you
And
understand?
do you know
Close
the stars don't the spaces between the stars don't get bigger and smaller like it is happening in your version?
No, it's not.
Don't take
made it
away
up.
the sky.
The
Don't
same
do it.
distance is between the stars
Give
no
me-
matter where they're rotating.
I
Y'all
need
have to
my
call that
space.
perspective.
I need
Y'all have
my
to call that
sky.
perspective.
I'm
It's
so
the only
confused.
global.
I don't see I don't see how this proves anything. It's literally just a fucking rotating sky at 180 degrees field of
I
view.
think what
mean,
it does is
I know, they
it
think
takes
it's
away
true.
your guys' only bit of proof. Is you always appeal to. We know
mean,
And
it's the,
models.
we know this is the shape because of the sky, and we're
But-
demonstrating that we can have the exact same sky with a different shape.
you
That's
really.
that's what's important about it.
Yeah,
But
exactly.
let's
And
be
wait,
honest.
and what they're arguing against is they've come up with some arguments against the idea that there's a giant dome over top of the Earth, right? And so they just keep on arguing from that. They're not even actually responding to the true argument, which is that it's a personalized dome. Like this is provable because we can go take measurements on the Earth and prove it. We can also go look at anticorpuscular rays and prove it. And even suncalc.org globe model has to map the sun in a 360-degree field of view.
Okay.
You understand?
So I think your
And they have to
presentation
use
was
perspective. And they have to use
absolutely.
perspective for the
Yeah, I
sun
just
and
said
the
something.
stars.
Fine.
Yeah, go ahead.
I think your
Go ahead, Matt.
presentation was absolutely brilliant yesterday. It's a shame about the sound, but I think if you were able to do it again, but have the sound going, I think it's it's really worthwhile to produce that again. And
Yeah,
hone it
no, I
in.
think what I'm going to do, bro, is I'm going to do the presentation with sound and make it a short video that's like 10 minutes so that people can just share it that way.
But let's be honest, guys. Did the globers ever had any proof regarding the sky? I mean, any sane person looking at star trails being completely straight, and they would correlate this for being on a sphere that is tilted and wobbling and flying from an ever-expanding void of darkness at 67,000 miles per hour while speeding and accelerating and slowing down simultaneously. Like who would consider? I'm talking about the stars. Who would consider that lights would behave this way and give you such a clean and stationary side? It's absolutely ridiculous what you guys think reality might be.
Well, hold
You
on.
have
This
been
is a
completely fooled,
hold
and
on.
you don't even realize it. Like because you're not even considering how stupid the idea is that you're on a moving spinning ball that shows you perfect star trails, as if that's
Poor
a
guy.
thing, you know?
Wait.
Magic light.
Okay, but this is the point here. Even in their own paradigm, with suncalc.org mapping out the crepuscular and anticrepuscular rays, you have a 360-degree field of view all the way around you. If you bust a 360, and then to map out the visibility of the sun and the anticrepuscular and crepuscular rays, you literally use this circle field of view all the way around you.
Okay.
I tried
Even
to
on the
demonstrate
globe.
this when I showed SunCalc and the divergence and convergence. It's all they have to call perspective for that phenomenon.
There is no
But
divergence and convergence. Even Witsit will tell you that.
go to SunCalc. That's what we see, though, right?
Can I?
I don't
Witsit,
see
you
it.
want to teach your own flat earthers your model because they don't understand it. They've all got different ideas of
saying
what's
you don't
going on in the sky.
We're saying that
She'll
what we
argue
see in
with me
the
and
sky.
SunCalc and Stellarium. She doesn't care about any of the globe programs. She just
Yeah,
will
this
just
is time and
ignore
date,
'em, bro.
Stellarium, and SunCalc. Okay, so if you guys
Okay.
deny the construct, you deny your own model, right?
Wait.
This is how we have to use this to map it out even on the globe. And again, this is suncalc.org mapping out the crepuscular and anticrepuscular rays, showing this very same thing that I'm explaining, which is that there's a 360-degree field of view all the way around you, and that's the limit to how far you can see the sun, and that you have this optical effect fitting within the sun.
Yeah, but then you claim that the southern stars are not real, or that they're a reflection of the northern stars, which they're not even close to a reflection
Never
of.
claimed they're a
So that-
reflection of the
They
northern
can't be reflections.
Wait.
In this program, they can't be.
Wait. Hold on. Can I just? Wait.
They
Hold on.
can't be reflections. Trouble.
Well, how do you possible way? Yeah, so Witsit knows that they're not actually separating and conjoining like this other guy keeps insisting that they're doing.
Well, no, he's saying it's apparent.
Now that's what Witsit says, but this other guy doesn't say that. This other guy that constantly
They have to be
Let me-
doing
then
that
the next
because
person
they have
seeing
to
the
be-
same thing sees them converging and diverging at different places.
They,
They're
well,
not
they, have to
converging.
understand, they have to be doing that
knows they're
because
not.
when we see the anticrepuscular rays behind us, but the sun's in front of us, we know the sun's not actually behind us. So no matter what you think the Earth is, it has to just be perspective causing that effect.
Right, and that's my whole point. When I made all them videos and I showed the convergence and divergence and SunCalc and Stellarium and on
there is
Google, that
convergence
royal.
divergence.
Hold on, real quick. Let me finish. When I showed all that stuff, that was globe killer. In other words, you have to either claim it's perspective
Globe killer.
or it's really
Just
happening
let him
because
talk.
that's what we see, right? I was almost done.
Okay.
Either you claim perspective, which kills the globe, or that it's really happening, which kills the globe.
Can I just jump in real fast? Witsit, is this the end of your little presentation? Like, if so, I
No,
don't
I
really
want you to acknowledge what I just said.
What was that?
Don't know what I just said?
Well, I mean, everyone else was talking. Can you repeat yourself?
Even in your own paradigm, using suncalc.org to map out the phenomena of crepuscular and anticrepuscular rays, you're using a 360-degree field of view all the way around you, drawing a circle, and then explaining perspective relative to that circular view.
That's how 3D worlds work. You rotate. You could rotate. I mean, that goes without saying. Literally, the objects are around you. That's how
It goes
3D
without
works.
saying we have a limit of
Even on
perspective.
you rotate a sphere.
Wait, are you saying it goes without saying we have a limit of perspective in a circle around us?
Not a
But it
limited.
doesn't
Not a
explain the
limited
Then why is it
perspective.
draw a circular limit of perspective here?
Wait, what limit are you? Wait, hold on. What is this limit thing coming
So you
from?
don't understand the picture?
All
What-
I'm saying. Go ahead.
Do you not
Go
see
ahead.
that the sun is clearly within the circle? The visible light is within the circle.
Okay.
Okay.
So it's
So
the
it
same
is
on a
a limit.
globe. Yeah, you've got a personal atmospheric dome on a globe as well.
Correct.
I feel like we sort of jump. Okay, hold on. So what was the argument again? Because all I'm saying is that in a 3D world, right, which we live in, right, it goes without saying that you can rotate around, right, and have 360 rotation. So yes, naturally things will be around you, and therefore naturally things you could map them out using 360, was it horizontally and vertically, whatever. That goes without saying. But I think you're sort of like jumping, not the gun, but you're sort of like throwing in this extra part with like, what was it, limiting or something? Can you explain that part?
Yeah, this
You
is
know,
from the
yeah.
observer's position. This is the limit of your perspective. They're saying, well, just because this is as far as you can see, it makes the anticorpuscular rays appear to be converging to a point because you can't see further than that.
No, I don't think anyone claims that. I mean, they always converge. Even if you had like infinite resolution, they would still converge. But just maybe they may not meet per se, but they would get really close. They would still converge.
If I zoom in, what will happen to the optical convergence?
I mean, they're still converging.
Will they change?
What would change? The way how much they converge, or whatever? Or like,
Yeah.
what are you talking?
Yeah.
No, they'd be converging at the same amount. You zoom in, they'd still be converging.
Wow, that's crazy. So if I zoom in on a railroad track, what happens?
They're still converging.
At the same rate.
Yeah.
So you don't even understand it. So like if I'm standing on a railroad track and it looks like they're converging, if I pull out a high zoom camera and zoom in, you're going to start to see that railroad track spread back apart.
No, I mean they're still converging, but like I get what you're getting at. Yeah, sure. If you like zoom in, there's like more, but they're still converging though. I mean,
That's a non sequitur.
I'm not really sure what you're like arguing about.
Yeah, I get it. So this is based on what we see as an observer. From an observer's position, we can only see so far in each direction. That gives us a 360-degree field of view if we're bussing around, right?
Wait, hold on. They're still converging. Even if you zoom in, they're still converging. They still have an angular size. The angular size between those railroad tracks, whatever, it's still the same size even if you zoom in. All right, I get your argument, but they still have that same angular size, so they still were converging. Like you're
Hey, my guy, they will start to optically spread out as you zoom in. Do you understand?
Okay,
that?
but the angular size is still the same though.
Yeah, you're changing your perspective ratio essentially if you start zooming in like that.
Oh no, well that's not what
converge because the freaking camera also can't see forever.
Oh, I get that argument. When I say converge, I mean like they're still angled the way that they're angled is what I was trying to go at. Because I mean like there's
non sequitur.
Okay,
I think they're under the impression, dude.
Yeah, and we have the same telescopes have a limit as well, right? Like when we take actual angles to the stars, we have a limit to how far we can see. You guys seem to think that light travels infinitely and that we can see 46 billion light years away, but that's actually insane, right? Like that's not
Arma, do you think on a flat Earth there'd be a direction we'd look and not see any stars or something? I'm just curious. Like to me, it seems like he's thinking in the south there'd be a direction we look and there'd be no stars or something. Like is that what you're thinking?
You would still have stars, but you wouldn't have a center point of rotation. And I'll be glad to show you or not show you. I'd be I want to like share my little paradox, whatever that I had earlier, but I mean, I just
can't not have a rotation, bro. You can't. It's not possible. And with a dome of view, you can't not have a counter rotation.
This is what's so funny. Think about this. So they're saying there's no limit to our perspective, right? So then, shouldn't I see half the sky?
You're talking about field of view. We're talking about in terms of like distance.
Oh, so there is a limit to my field of not field of view.
Like, it is field of view. Field of view. If you would need a field of view of 180 degrees to see all of the sky, or at least left to right. Maybe not up and top. Up
so
and down.
Are you
but
saying
left
I
to
can
right.
Technically,
see half
you see
the sky from one position on the Earth?
You see 6 constellations at a time.
Well, hold on. Okay, as a person, if you wanted to see from one end of the sky to the other end, right, you would need a field of view 180 degrees. But you're talking about something else, though. Hold on. Witsit talking about something else, though. In terms of being on the Earth, and in terms of the amount of stars that you can see, you should be able to see about 50, if not even slightly more than 50. Yeah, 50% of the celestial sphere. You should be.
Yeah. So can we?
Yeah.
No, we can't. So that's what I'm saying. Most globers seem to think that you can actually go out in the world and see half the sky.
Well, what makes you say we don't?
You can only see a few miles around you, bro. What are you talking about?
Quite evidence that we do.
Okay, show us.
Yeah, that's what I'm saying. Yeah, show me that you see half the sky.
Okay, I mean, I guess first off, I'm pretty sure if you want to use Stellarium so much, I'm pretty sure Stellarium shows us half the sky, but
no,
sure,
Stellarium specifically doesn't.
You sure about that?
Yeah, Stellarium shows within your azimuthal grid what you can see and what angles you see, and it's not half the sky.
Can you show me that?
Yeah, go to Stellarium.
Let me see this shit.
So, okay, look, here's the actual point here to drive this home. Even in your own paradigm, you need to use the circular limit of vision. You guys can say no, but this is how we observe the world right here. We have an observer, we have 360 degrees around us, we can turn around. This is how we map everything. Right here, this is how we map the whole sky, because this is how we see. We have a limit to how far we can see. We map it all based on that
Hey,
limit.
Witsit, I had one question, dude. You know how they say like somebody in the UK, like yesterday, I was debating a Glober about I think it was Eggshells or somebody posted it that you can see the moon in the northern hemisphere in one orientation, but the person in Australia see it upside down. So I shared a picture. Do you see it in the chat? It's not coming through on my end, but do you see it?
That's a different topic.
No, that's easy to explain.
No, it's not. Because
Dave
what
Weiss
we
has
view
even
in the
explained that
sky.
if you put a
Then I'm
moon
wondering.
above you on the ceiling and you walk from side to side, it's going to look different.
Wagon wheel, bro. Wagon wheel.
I want to
Wagon
point
wheel.
this out to you guys real fast too. So these are of course we have like the perihelion, then we have like sun dogs and halos, moon halos as well. Okay, even observatories catch them. Now, first of all, this makes perfect sense understanding that we have an azimuthal grid of vision. This isn't the dome over the whole Earth. The dome would be way bigger than this, right? But this is based on our limit of perspective. We have curved visual space, right? So when we have something in the sky that can reflect the light, we'll see these limits being illuminated, the curved visual space. The globe doesn't actually have an explanation for the shape, for why it's not equidistant. Since the light's coming out from the source and they claim it's ice crystals all in the sky, there should be little circles everywhere going all the way out and continuing out. They don't have an explanation for why it starts to go the other way at the top. They also have to claim that the ice crystals are parallel to a flat surface below it. This is the globe's, and they admit they can't fully explain it. Okay, but what this shows is that we have a personalized dome of view right here. This is what we're inside this. That's why we see this when we look at the sun. The globe can't explain. Again, they say that these ice crystals are perfectly parallel to a flat surface below, in theory. And look how far out you can get them to go. How far out is the Earth flat? Right? And again, they don't even explain this part right here. I don't know if you can see my cursor, but where it's going up, where it begins to change direction.
Okay, hold on.
It changes direction. Look right here.
Witsit. I'm on Stellarium right now, and I'm seeing more. I'm seeing about 50%. Why did you lie?
You put your azimuthal grid on, and you can see half the sky.
You're talking about stars infinite distance away. We're talking about the sky, period. Like you can only see a portion of the sky.
I get that. Yeah, in terms of like the fucking clouds, of course you're gonna see less than that. I'm talking about the fucking celestial
Well,
sphere.
think about this, Dharma. Think about this. If you take a plane that's flying above the ground about 10 miles in front of you, you're going to see it for a little portion.
Disappears. Right? I know. I got that. I literally agree with you.
Hold on, man. Hold on. Let me paint this picture for everybody, bro. Why are you interrupting me, bro? So then now,
my bad.
It's 10 miles away from us and it's flying across the sky. We're going to see, okay, depending on where it's at, okay, it's north of us. And then we raise it up, let's say a mile and fly across the sky. And then we raise it up another mile and fly across the sky. You're going to see a little dome, and every time it raises up a mile, it's going to make a bigger arc if it's north or south of us, man. That's just how we see, bro.
Yeah, but when I was talking to Witsit earlier, I was saying specifically, I literally said celestial sphere, all right? In terms of celestial sphere, we should see 50% of it. And what I'm getting here in Stellarium is 50%, all right? I literally have the azimuthal grid of vision up, right? And we have, what is that? We got 10 degrees, 20 degrees, 30 degrees. I literally have up to 90, right, above me because I'm at the North Pole right now. And then all the way down to the what do you call it? The horizon, whatever. I got down to 0. Let me also pull up the. Actually, no, that's actually not azimuthal grid. That's actually equatorial grid. Okay, all right. Yeah, exactly.
You can see half the sky.
Half of the celestial sphere. I'm not the sky itself on the Earth. That's a different thing. But in terms of the celestial sphere.
Oh, well, shouldn't we see half the sky itself on the globe Earth?
You mean in terms of like clouds and shit up there? Then no.
Wow. What are you talking about clouds?
No,
that's part of the sky.
On a globe, you're on the side of a sphere, so you'd be looking out and seeing half the sky. You'd be looking out.
Okay. When you say sky, do you mean celestial sphere, or do you mean like the clouds and planes and all that shit up there? Like, what are you referring to?
Like the stars. The only thing that should be blocking how far we can see in the sky should be the Earth.
Yeah, so it's a celestial sphere. That's why. Yeah, so yes, we should see 50, and from Solarium, from the looks of it, yeah, we are getting 50.
So if I
Okay.
go out into reality, can I see that?
Sure. I don't see why
Okay, that's
not.
what
I'm
I
pretty
need
sure.
evidence for. And by the
Well,
way,
no,
look,
you made the claim that we don't. Shouldn't you be the one showing us evidence that we
we
don't?
don't know
Like,
how evidence works, right? So,
you
like,
literally made the claim. You brought it up first. You literally said we don't see that. So I was telling you, show
yeah,
me,
you're
and you were like,
asking to
oh
prove
no,
a
show me.
negative. I mean, technically, I could go out there and not see it, and you guys will just make excuses. So, how about you show me actually seeing half the sky from the Earth that you claim's a globe? And by
Hold
the
on.
way,
Let me
just
make
so,
this
just so the
point real
room
quick.
knows, ARMA's excuse for this, because again, they have crepuscular and anticorpuscular rays, and they look like they're converging down on the horizon, right, 180 degrees away from each other. So when we look at them, we see a curve in the sky. Just like if you take a dome, you're going to see it curve over from point to point down onto the perceivable limit, right? You're going to see the curve. That's what we see in reality. We literally see a curve. ARMA said that this is because it's a wide-angle lens.
Yeah, let me
part,
say.
yeah, that's
Let me say
good,
this,
yeah.
Arma. This is very important. If we're on
Hey,
one side of the globe, if we're on one side of the globe, look at the
one
equator.
more time.
What?
Hey, y'all, listen to this. It's very important. If we're on one side of the globe and we're at the equator, looking at the north and south celestial points. Okay, now we're on the other side of the globe, looking at the north-south celestial points. So, Arma, we see the whole entire. We see every star between the two of us. We see every star, right? So, what's in between? So, the rest of the Earth that's in between us. How the fuck does that work? Do we share it, or
Yeah,
you'd
they
agree
see.
that what you're saying is 50% of the sky? Then, if I'm on the opposite side of the equator, then me and you can see the entire night sky, right? So,
No,
what's
man.
in between us, Arma?
No, you're always. Yeah,
Here's the deal. Here's the deal. You can check this on Stellarium. It's sunset for me right now. 90 degrees away from me is noon. At 180 degrees from me is sunrise. That's just the way it is.
Dude, that's how we made the globe, Left-Wing. The fact that you guys don't comprehend that we made the globe by looking at the sky blows my mind.
well,
Yeah.
let's not.
Well,
Let's
I'm
go.
looking at half. I can see half the sky for sure.
Well, hold on. Wait, seriously, we need
Okay.
we need to go back to that little claim of you saying you're saying you don't prove a negative, whatever. But you literally said, okay, you literally said we don't see. All right, 50%. All right, so you should be making the claim in general. You can't make a claim without some kind of evidence or proof, whatever. Right? I mean,
You're
just
just
imagine.
ignoring my point, bro. Howard just jumped in. Okay, so what's in, so if I'm on one side of the equator and you're on the other, we're seeing the entire night sky.
Yes,
Okay, what
between
if
the two of
Howard
us.
is in?
Yes.
What if Howard is in between us? What the fuck is he seeing? A shared night sky? Like we're
He's
on
seeing.
entire ends of the globe, but we're seeing the whole entire sky.
Yes.
So hold on. So we're in between us. What is that? Just the fucking Twilight Zone or what?
Yes.
I'm just
So okay, how about this? So let's divide the sky into 4 sections: red, yellow, green, and blue. All right. You see red, yellow. All right, and Howard sees green and blue. All right. The person in between would see green and yellow, and the other guy on the other side would see blue and red. All right. There you go. It's not
Hey,
hard.
this is what real fast though, before this gets lost. I want to understand. You're saying that this is just because of a wide angle lens. So if we were using a normal lens, what would they look like?
I'm not sure. I would have to get another lens to see how that looks.
Okay, so if these are converging down onto the horizon, and you're claiming the light's going above our head, because of course, if the sun is just like 1 degree above the Earth on your model, it's like 1.3 million miles above the Earth or something crazy, right? So if you guys are claiming that the light rays are going over my head, but we see them converging down on each horizon, so how does it go from a point on the horizon over my head back down to a point on the other horizon without curving?
Once again, it has to do with like 3D space and whatnot. I'm pretty sure I could like literally this would work with anything. Like, if you had power lines, whatever, I could probably model this in Blender. In fact, but Blender doesn't use like any curving thing. It literally just uses trigonometry and I guess a field of view or something. I guess maybe the field of view kind of throws in that sort of curving effect, whatever. But and that maybe supports your argument. But that still doesn't explain southern star rotations, whatever.
Wait,
You're
wait,
somehow
stop
equating the two, though.
scattergunning. You do this every time. Every time you have to concede, you just end your concession with, but it doesn't work, and you change the subject. No, you said that the only reason this looks like it's curved is because of a wide angle lens. I'm explaining to you that doesn't make any sense because we see them appear to converge on each horizon. So if I take the point on the horizon and I draw over my head back down to the convergence point on the other horizon, how can you do that without it curving?
I don't know if I'm 100% following. Remember, I think.
Hey, let me
all
put it
right,
like this. You should be able to show us the sun doing a perfect circle from the North Pole. You should show the sun at 23 point whatever degrees doing a perfect circle and not going up or down. Let's see that.
What?
why would it go down? If I'm at the North Pole, why would the sun appear to drop for any reason? I mean, if it's not perspective, then it's doing a perfect circle around me. If I'm the one spinning, and I'm at the exact North Pole, I'm at the exact point of rotation. So go to the South Pole, whatever point you think is the South Pole of rotation, and show me the sun 23 degrees above the sky, doing a perfect circle around the sky, because that's what would have to happen if I'm rotating.
No, if it was 23,
Perfect
23
circle. No
well, hold on,
circle.
hold on. If it was 23 degrees, wait, above what? Above the horizon is what you're saying? 23 degrees?
No, like on the solstice, on the southern hemisphere's summer solstice. If I'm at the exact center of rotation at the South Pole, you should be able to show me a sun do a perfect circle 23 degrees above the horizon. If I'm the one spinning,
23 degrees above the horizon?
No.
once again, if
That doesn't
I'm
make any
the one
sense.
spinning, oh god, dude.
You said, hold on, 23 degrees above the horizon. So basically, if we, am I getting that correct? Is that correct? You said 23 degrees above the horizon.
23.4 degrees above the horizon.
Yeah,
is
no,
where the sun starts at summer solstice in the south for the southern. Okay, now
Yeah,
why
it
would it
shouldn't
go
do that.
down if I'm at the exact center of rotation? Why would it go down?
Okay, so that doesn't. Maybe I should model this out in Blender, all right? Because this doesn't. What you're saying right now doesn't really make any sense. But I
No,
could.
this is
Yeah.
wild, bro. Okay, let's
Your
just
brain won't let you comprehend it, bro.
No,
let's
no, no.
recap. For
Right now,
one, he had to
right now in Blender, right?
concede.
Because I'm pretty
he had to
sure.
con-
Yeah, there was a point that Armo was trying to respond to Witsit, and then Brian came in and just brought up some whole new thing.
Well, yeah, I want you to concede, man. Like, okay, like we can recap if you want, because I feel like I'm almost picking on you at this point, right? But
Sure, if you think you're picking on me.
yeah, you're all by yourself, right? You're kind of getting dogpiled. Don't take it the wrong way. So the point is that we see them look like they're converging on the horizon, okay? From both sides, 180 degrees. So if you're claiming it goes over our head, to draw from one point on the ground and then go over your head back down to another point on the ground, it has to curve. Secondly, the celestial sphere does not show literally 50% of the sky.
Well, hold on.
You can prove this by understanding you can't see the alleged southern pole rotation, the circumpolar rotation from just below the equator. You have to go to a way lower latitude than that.
You sure about that?
See literally 50% of the sky.
Are you sure about that? You said at the equator you can't see the southern pole.
So you're saying that we can see the southern celestial pole from the equator?
Well, technically you shouldn't, because it would be exactly on the horizon, I guess. But no, that's not really true either. Really, I mean, because technically speaking, right? Because the Earth is curving, right? Technically there is a 0.04 degree amount. Yeah, technically you should. I mean, it's probably not like super visible, but technically it should be like a smidge of it there. I would say.
This would debunk the globe, though, if you can't see it, right? I mean,
like I said, it would be like a smidge, like a smidge amount. So you probably can't make it out. So
I believe that you might be incorrect with it. As far as I understand, Southern Cross can be seen from Texas
Southern Cross
and
isn't the
Florida.
southern celestial pole.
No.
Yeah. Hold on. So the pole.
You can see. You can
from Texas.
Apparently. Yeah. Apparently,
Nope.
Florida and Florida and Texas. Yeah. Just go look it up. Apparently,
Yeah, the Acrux is the southernmost point of the Southern Cross, and it's at 27.5 degrees, I think. So yeah, we can see it. If I go just a little bit south, I can see a little portion of it where I'm at, but I can't see the southernmost star. But still, I was sorry for changing the subject. I was just trying to elaborate on what Austin's saying, because they think about the sun a lot better and practically, and so these shadows we see for the North Pole, like they try and show us 24-hour shadows. It's the same concept. Like the shadows pretty much should do a perfect circle from these 24-hour cams on the government cams, but that's not what we see. So we know there's horse shit afoot.
Yeah, I just wanted to say that I kind of liked it. When I first saw it, I thought, okay, this makes sense. And then I was sort of picturing in my head walking to the forest, southern point, and seeing that southern rotation, and that was fucking me up. I couldn't get my head around it. And also, I think you're supposed to be able to see Polaris from the equator also, which I couldn't, the two wouldn't marry up in my head. But this has made it much clearer, so I appreciate it, Austin.
Yeah. No problem.
Well, the thing is, though.
Hey, me too, man. Me too, by the way. Good presentation.
Does this take place on a pole? Because this also happens in my
You're roboting, man. So what I was going to ask Austin, the thing is, so like crepuscular and anticrepuscular rays can be viewed anywhere, on the Earth. You're going to see that kind of convergence, divergence, and if they were spinning, you would see the rotation and counter rotation. But to use that explanation as the southern stars, wouldn't that have happened if you were, let's say, like north of the equator? Wouldn't you see
Let
a
me say
southern
this.
rotation everywhere?
Give me
If
a
it was
shot at it,
just
Gio.
because Brian, you're interrupting. If it was just because of perspective, wouldn't you always see a southern rotation at every point?
You're going to see them start to look kind of funky because you're looking in that way. You're not going to see a full convergence point.
But isn't there something different about the sky in the south that makes it that convergence? Meaning, like if you were in North Dakota or something, you're going to see the northern rotation, but you're not going to see a southern rotation.
Yeah, but where you're at, if you're near the equator, you're going to see that point moving. Okay,
Well,
if you're actually at the equator, then you're going to see the opposite of the sun. That's just a point. So everybody's going to see that point as the center of their rotation, and that's only if the rotation's getting smaller. So in other words, that rotation is. Go ahead. Sorry.
Well, I mean, but why don't we apply these same rules to the northern sky?
Because the northern rotation isn't a facet of human perspective, right? It's
barely moving.
Okay. Okay.
Yeah. It
Okay.
is physical reality. The stars are rotating one way.
Well, how do you know that it's not the same in the south, that it is physical reality that they're rotating the other way? Because what I was saying is that if it was just a matter of perspective, like you can get crepuscular and anticrepuscular rays anywhere on Earth. You don't have to be in the north or south. So if it was just the stars or just perspective, it seems like you would always get a southern rotation anywhere you are on Earth. But instead, we only get it when you're in the south.
Only when you're
What
far
if you're
enough
looking
away
east?
from Polaris where you can't see Polaris anymore. So, in other words, only in the south while looking south.
What if you're looking east, Gio? If I'm looking east, am I going to see a rotation? If I'm looking east and the sun is, and then the anti-spot is directly behind me, am I going to see some type of rotation? No, I'm going to see them just going and ending up in a point behind me, right? It's only if you're looking north or south, bro.
But what dictates what dictates the midpoint though? Like how you get like the equatorial rotation. Like why is it like specifically there? Like that doesn't really. And what happens if we extend the flat Earth even further and we go further out? Like
where are the star lapses armor of the South Pole straight up? Can you show me some of those 90 degrees?
Wait for what now?
The South Pole. The South Pole time lapse. Right?
Bam, that's my point right there, dog. Shane, that's what I'm talking about. If they could show us this direct rotation overhead, look, they showed us star trail bullshit. I want to see it with the sun. It should be the same thing with the sun. If it's at 23 degrees, it should do a perfect circle at the South Pole. But when we look at them flags, we see the shadow going up and down, and working its way around. So they can't demonstrate this horse shit.
Well, hold on, real fast, Brian. I will give you that. I actually did the summer solstice thingy on my little model, whatever, and I have the camera at the South Pole, whatever, and yeah, the sun does seem to stay 23, which is correct. But those videos though, where they show like the sun, in the South Pole, whatever, right? Those aren't like claimed to be at the exact center, right?
Ah, okay. So all the spots they claim as the South Pole, they're really not the South Pole. But look, to me, dead. Show me the sun do a full circle. If you show me a sun do a full circle at 23.5 degrees and prove where you're at, flat Earth over. But they would have already done this, Arma. If they could have showed this, they fucking already would have, bro.
Yeah, but here's the thing though. Even if it's not doing like a full circle like above, like even if it dips a little bit, isn't that still like problematic though? The fact that you have that much like sun at once, like I don't even like how do you even like you basically you get to the point where the sun is dipping it's still in front of you. You know what I'm saying?
So you agree they haven't killed the flat Earth with the sun in Antarctica? They could kill it like that, and they haven't done it. Will you give me that?
But I feel like sure. But sure, but I feel like the ones, but I feel like the ones that are even out though, the ones that like the sun dips a little bit, I feel like that's still also for the most part, destroys the flat Earth unless you have some kind of bending light. If you don't have if you don't have bending light, then that should destroy it instantly. The fact that
Here's
you
where
have
it
that
gets
much
modeled.
sunlight
Here's where it gets
and
modeled. I
sun.
see what you're saying, but they haven't even showed us that in the north either, bro. So like, do they really know exactly where the fuck everything is? You're giving them too much credit. Like we've got a model, it fucking works, but dude, they haven't showed this in the north or the fucking south, bro. I mean, they've showed the 24-hour sun, but it's dipping down and all that. Like, bro, it shouldn't be an act of God to go to these geographic positions, okay, and prove your fucking model, bro. It hadn't been done in no way, shape, or form.
Yes. No.
Only if you're perpendicular.
You talking about
To see the
P-Brain?
rotation, you got the stars got to be perpendicular.
You're talking about P-Brain's one of his where it shows like 4 clusters kind of stars. Right there. Yeah.
Yeah, that's not a quadrupole, but yeah.
Just out of curiosity.
I always said that one was confusing.
Well,
Oh, so there's 4 celestial poles now. So now you're saying there's 5 celestial. Like, do you not know? Are you guys just making up as many as you need?
All right, hold on. I'm gonna
No,
have
the
to mute
pole
people
is
that are-
perpendicular.
okay.
Every
Yeah.
that is one model. I did it with 3, but we got it. The stars that are perpendicular to
I'm
us.
not clear. Now Brian's going to sideswipe into something else. What are you saying to perspective? You were interrupted originally. Can you repeat that? Try to, if no one interrupts, we can go through. Yeah.
Okay, so this is just each observation is obviously individual to the observer. Not all 4 of these people can actually see anything known as the South Celestial Pole at the same time, but it doesn't matter. There's just going to be an optical convergence around a singular point in the sky for each observer, and actually they'll technically not be directly ahead. It'll be slightly around, but it's just an optical effect relative to each observer. Like just like the anti-crepuscular rays looks like they converge into a singular point. When you're looking south and the stars are moving over top of you counterclockwise, you're going to perceive them the opposite direction going around a singular point, just like here at the bottom. And that's going to happen. That's going to happen for each person because
Yeah,
you're
so-
Perpendicular to each person.
Yeah. Well, I have a. Can I bring up my paradox real fast? Because fair enough. Okay.
No, bro. Only perpendicular, bro. Only the perpendicular.
Well,
There's only one point perpendicular to each person, bro.
that doesn't make any sense. So, well, no. You don't mind what's it?
Yeah, go ahead.
Right. So most of the known world, like 80 to 90%, sees the northern physical actual rotation. We live in the northern hemisphere. We see the actual center point. Only when you get far enough away from that center point does the counter convergence induced by perspective come into play. And again, only in the south, while looking south. Does that help at all, or is that just more?
Yeah, so each person's going to have a perpendicular. There's only one point for each person that's perpendicular to the north, and each person is going to have that around the flat Earth, a point that's perpendicular, and everything's going to rotate around it due to perspective. There's no getting
So
around it.
what makes north in the center? Why can't south be in the center?
I think maybe
Why
the
can't
point-
south be in the center? How do you know north in the center? Like you could flip this.
Well, I was just trying to respond, but I haven't. Yeah, it's a lot of people wanting to get in. All right, so like let's say with crepuscular and anticripuscular rays, like no matter where you are on Earth, you can get those. You can get the convergence, at one, like where the sun's setting and then 180 degrees, you're going to get that thing, you're going to get that effect. So if the stars, the southern star rotation was only caused by your personal atmospheric dome, then it seems like anywhere you would be on Earth, you would have you would have a northern rotation and a southern rotation and an equatorial equator in your personal dome. The fact that it only occurs in certain positioning, like when you go further south or further north, to me shows that it is something in the actual sky that is occurring, not just the personal field of view.
Which is
Can I take
sound.
this one?
That's sound logic.
It's a course, and it's the northern point from the course and the southern point from the course. This is why you have the appearance of oppositions. Right?
Gio, what if the sun was
All right,
Polaris?
Can someone
bro?
actually respond
If
to
the
what I
sun was
said that would be on
Polaris,
topic?
The course of the course of the rotation, right? I was talking.
give me this one. Give me this one. So if the
We
sun
almost
was
need to just
Polaris,
mute everyone so we can have a conversation, because everyone's going to want to jump in and pull in different points. I mean, you brought up one thing. I responded to one small part of it. I don't know if it's possible with everyone in here right now. I don't know.
All right.
for fuck's sake.
So you said you're asking about is there a physical? Is this the celestial equator question again? So like Witsit said yesterday, right? They deduced the globe from the sky. So the latitude literally equals the decline of Polaris as you get away from it, right? And it's the counter for the counter rotation. So as you go south of the equator, each latitude would mark, the southern rotation point, increasing an elevation on your south pole, right? It is a facet of perspective for each person. Have you guys seen there's a video of a guy taking star trails in Sydney on the southern pole, and at different times and different nights, it's at different elevations, which would make it weird as a physical point at the bottom of a ball converging for everyone, and exactly accurate if it's an optical convergence specific to each observer.
Right. So picture every star.
Wait,
as
Shane, real quick,
anticripuscular.
Shane, real quick, Shane. What that shit that you just said, Shane, about the guy taking the altitude or whatever, the measurement. Do you have that as a link?
Of course.
I would like to see that, because that's very interesting. I never heard of that before.
Yeah, because if that was happening, that means all the stars in the sky would be moving. Because if that's happening in one place above the Australian sky, then all the stars in the sky would be moving up and down. How come it's only seen here and it's not filmed all over the world?
How the fuck
Or
did
just-
I say something directly to Shane? How the fuck did I say something directly to Shane and
Sorry.
other people answered?
Sorry. I'll mute. Sorry.
There it is.
Well, hold on. Gio has a point though. Look at those gifs. Look at those gifs in the chat. Right, that lens.
I got the answer, bro. I got the answer. But you keep cutting me off, bro. Okay, bro. Okay. There's only one spot in the sky that's not moving. Bro, I used to think like Geo. I'm trying to respond directly to Geo, bro. Nobody has done it. Okay, so there's only one spot in the sky that doesn't move. So 180 degrees to that, no matter where you're at, is the only place you're going to see an opposite rotation. In other words, it's got to be perpendicular. So if you look to the east or west, so picture every star as having its own corpuscular rays coming right at each individual. That's how we're all going to see it. So it's only going to be 180 degrees from the actual point that's not moving. Everything else is going to be doing a certain size rotation perpendicular to that spot, brother.
Why can't I see the corpuscular rays coming from the star? If you're claiming that every star has corpuscular rays, why don't I see the ray?
No, I was just trying to get him to imagine it.
Okay.
Well, it sounds like to hash through what you're bringing up, it would have to be me, you, Witsit, and Shane are the only ones speaking. And so we could do an event at some point, or we could do, something, because obviously, on a, but with the
Yeah.
Yeah, I'll back off, bro. All right.
I'm going to drop out.
yeah, because with an open panel, everybody wants to bring in.
This is so weird.
What? Yeah. What's the question? Yeah, I didn't quite get it though. I didn't quite get what he was describing. Oh, right. Yeah, so it's like human perspective on a massive grand scale. It's the only thing we have comparisons for. The reason that we see anti-corpuscular and corpuscular rays is because it's so far above us that our vision wraps it in a dome around us. And if you just tilt that dome 45 degrees and expect what would happen at night and have the stars pass above you east to west in perfect circles, then you can imagine that it kind of warps it around you, as all the modeling shows, as the dome footage shows, as a bunch of stuff in which its presentation actually showed your perspective doing that, right? And again, you only see it when you're far enough away from the center of rotation. Otherwise, you see everything extending outward in concentric circles from the source. Only when you get to the equator and you see the equatorial view, where you kind of see the both poles on the on 90 degrees on each horizon. And that is what you would see. And the star trails do show that, right? You don't see you see the beginnings of one pole and the beginnings of the other just creeping over the horizon. And then from that point on, or south of the equator, you no longer see the northern rotation point. It's below your horizon. You do see the stars circling around it in that direction, but you can't see the actual focal point. And the further south you go, the higher the focal point in the south induced by your perspective gets. If that makes sense.
Yeah, but the idea of the perspective, but the perspective thing indicates that it's something within your personal field of view, your personal kind of region. Meaning, like, if you're getting corpuscular and anticorpuscular rays, those are converging in front of you and behind you because they're in that personal range. But with the stars, like, if that was the explanation for the stars, and we would get that southern and northern rotation everywhere. You would get it if you're in North Dakota, Texas, the equator. You would get it everywhere, and you would also have like a celestial equator in the center, just like with anticorpuscular rays, where they kind of, there's like that center line at the point at the top. But the fact that we only get that effect when you go further enough south or further enough north, to me, indicates that it's not just the personal field of view that's kind of warping the stars around you. There's something in the actual sky or in the actual environment that's creating that differentiation.
So I'm kind of confused by this argument. You say that in like the middle of the country, we should see the north-south pole and the equatorial view at all times. Oh, yeah, I don't think that's what's happening at all, though. It's not. It's an optically induced counter perspective, right, from every point south while looking south. I mean, it's a weird thing to grasp, man. But again, if you think about the limits of your vision during the day, like that's what creates anti-corpuscular rays and corpuscular rays, right? What just imagine like the sun is rising on like on the east horizon, and those corpuscular rays are emanating outward from it in perpetuity, right? Just onto infinity. And then you turn behind you, and you still would see the anti-corpuscular rays because you can't see the end of those light beams. You can't see where they end up. It's the limit of your perspective, and it converges them in a convergence point just because that's all it can do because it's the limit of your curved visual space, right? And that's during the day. And I'm saying it's the same thing at night while looking south because you have to be far enough away from the center, i.e., in the south, so past the equator. If you're anywhere as like the rest of the 88% of the world that lives close enough to the center of the focal point of the rotation to actually see it, then it looks normal and you're seeing a physical rotation. If you look south in the north, you can see the sort of the remnants of what would be maybe, right? But you have to get south to the equator to see the the equatorial view where you kind of get the counter convergence. You get both poles on the horizon, and then your counter convergence will just put it up further elevation from your horizon in the south. While looking south, the further south you go. Oh, oh, good. I'm gonna say good point about that. I asked Flat Earth Philosophy to come in here and take a chat with us about the stars and see if we can get that right. And that's going down on Thursday.
Yeah, sorry, I had to step away. What's going on?
Oh,
Because they're spaced out further on the outer rim?
Well, no. From my understanding, it's just like when you see crepuscular rays, right? And then you look behind you and you start to see the optical illusion of the anti-crepuscular rays. You don't actually see them all go to a point, right? You're at a certain distance closer to the actual sun. Right, so in theory, if you went far enough in the direction of the anticorpuscular, then you would get closer and you would see more and more closely the actual convergence point. It's like the same thing with the sky because there's a giant clock over top of us moving in actual direction. So if you look south, you're not going to see like the full convergence point because you're not far enough away from the actual source, just like with the crepuscular rays. Does that make sense? Shane, what do you think? What is your take?
no, I like that. That was very good. I think it would help if we played with Bislin's model though, because again, looking at that's kind of how it made sense to me for the first time was looking at that and moving it around and changing the latitude and going on the equator and going to the north and pushing it out south and saying, "Oh, I'm trying to
That's what I'm
understand.
saying, right? If you look at the crepuscular rays and you turn 180, you see anticrepuscular rays. You can actually see those anticrepuscular rays actually like converge all the way into a singular point. You can tell that they're optically appearing to converge into a singular point, though, because you can just follow the divergence of the rays, right? So, like in theory, if you were to go in that direction, you would see more and more of that convergence to the point. It's the same thing with the sky. We're under an actual rotation, right? A counterclockwise rotation around Polaris. You have to get far enough away to where Polaris is dipping down in your sky to where you're going to get close enough to the optical counter convergence in the opposite direction. Same thing with the anticrepuscular rays, just on a giant scale over the giant flat Earth.
So then, what do you think the stars are doing then? Do you think that they're just going out like fan blades, like a dartboard, basically in the sky, like going out for
Yes.
spacing out like that?
They could be spacing. I mean, like I do think the southern stars seem to be a bit more spaced. Yes, they
So you
are,
don't think
right?
there is an actual rotation in the south?
No, I think that it's one gigantic counterclockwise rotation, and I think it's probably flat. And so this just clicked with me the other day. I'll drop a picture, see if this clicks with you. I'm just glad that my objective is not to claim I fully understand the sky. It's to make flat earthers talk about it. Okay, so if we let me drop a picture. So imagine a dome, right? Now I think this goes for the Earth and for our personal vision. So just envision a dome, and here's a picture of it. Okay, so this is crude. I made this on Canva, but if you see this dome, right? Now, if you were to just like on a sphere, say you want to
It
draw
might be.
lines on this.
Do you have
Second.
a second screen that's not sharing?
Oh no, yeah. Here, I can probably just drag it into my PowerPoint right now.
Yeah.
I dropped it in the chat, but I'll just drop it on the. I forgot I was sharing. Okay, let me come
Oh,
over
just
here.
because if you're pointing, if you're wanting to refer to that one, we can't see it.
Yeah. Let me grab it out of the thing again. So just imagine in your mind like a dome, and just like on a sphere, here it is. Okay,
All right. Yeah. No,
just like on a sphere, right? If you were to draw lines around the sphere, they would as you get to the poles, they would get smaller and smaller circles, right? That if you drew lines around a sphere, we'll cut that sphere in half. Now we have a hemisphere because that's how we see. So if you were to draw circles around the inside of that dome, it's going to be bigger circles at the bottom, and then the circles are going to get smaller and smaller and smaller. They're going to be actual circles that are level and parallel to each other, going all the way up. So I think the stars is on one of those density layers. I think we actually have literal horizontal layers above us that are parallel, and they're all confined within this dome, and the stars are on one of them. I currently think the stars are on a flat plane above us. Does that make sense? Like if you were to look up, you would see these circles right here, and this small circle would be the highest up. You see what I'm saying?
Yeah, who said this years ago? Brian's Logic on Oakley's show. When I was first
Really?
learning about the flat Earth, suddenly Brian's Logic comes. I love Brian, by the way. And he comes and he's suddenly the sky's flat. I was like, what the fuck?
Yeah,
Sky's flat as well?
So
I
yeah,
think
it's like
Mitchell from
layering like a dartboard within a dome, essentially.
Yeah, like say you have a sphere and you draw these lines on them, right? Like on the surface of the sphere, they're gonna get smaller as you go to the pole. If you cut that sphere in half and then step inside of it and you looked up, you would see circles above you that are getting smaller and smaller, right? So I think this explains why when we look out from the side, we see the rainbow is a dome, but when we look at it from above, we see the circle. I think this is why whenever you can have like a halo right above you, it's a perfect circle. I think it's all optical, right? Like you look at it from the side, you're going to see the dome. But when you look at it straight up, right here, see, you're going to see a circle. Does that make sense? I think you're looking at this, and this is personal to you, and of course, our whole existence is fractal. So actually, it's also over the whole Earth, and it would continue down. It would technically be a sphere. We just live on the plane through the middle, so we only see the top half of our hemisphere of view because we can't see through the Earth.
So then, based on that, like on that little dome one on the left there that has the lines, how are the southern stars in your viewpoint like rotating in that, very tight circular fashion in the southern regions, in terms if it's mapped like this, if it's like a flat layer of stars within a dome.
Yeah, say the stars are at one of the lower layers, so it's on like one of the big circles, right? And it's just a now you could potentially have like tons of these circles, right? I mean, you could pick any. They don't even have to be evenly distributed or spaced or anything. But so as you go further out, I think that they'd be a slightly more spaced, but they're all going to be spinning counterclockwise, right? And then like just like with the crepuscular rays, anti-crepuscular rays are here. Oh my god. Right here, you have to, you're like, okay, the source of the light's directly behind you. So you aren't close enough to that anti-convergence, if you want to call it that, to see the point. So if you have to get far enough out from Polaris where it's going to drop in your latitude, this is how we made the globe, right? We took angles to Polaris as we went out, and we literally made latitudes based on the angle to Polaris. And then we get so far because it's dropping down our field of view that Polaris reaches the horizon. So now you're sufficiently far enough away from the source, so much so you can't even see it. Now when you turn around this mark, you're going to be close enough to the edge of the rotation to see the counter convergence. Well, you're viewing it all through your personal view. But if you were to put a dome directly over concentric circles, it's going to, in the middle, it's going to just look like circles. You're going to see the actual rotation in the middle. But as you get far enough out, you're going to actually see, and you look the opposite direction, you're going to see them move the other way optically. And then if you're far enough away from the center, you're going to see them converge in a point. That's why I think this video is really good. Yeah, I'll play this if you want to. Yeah, I think you guys should be able to hear it. It's just a couple minutes, but I think it's good.
Okay, so watch this.
Yeah, it's epic.
There it is. Sun's above your head, and then it sets. One more time. That's exactly what is happening, okay? Let's change latitudes now, and let's go to the North Pole. If you go to the North Pole, the North Star would be directly above your head at your zenith. So if this is the latitude of 45 degrees, because if the equator is here, this black line, that's 0 degrees. That's 45, which is right in the middle of 0 and 90 degrees. Okay, so the 45 degree parallel, the North Star is visible 45 degrees. The North Star would be here. Okay, so if you're at 90 degree north, the North Star is 90 degrees above your head. 40 degree, then it's 45 degrees above your head. Now, if you're at the equator, the North Star would be directly 90 degrees. You wouldn't even be able to see the North Star if you go past the equator. See? Watch, I'm gonna show you. But first, you're gonna see how it looks. See, now it arches. It's going this way because the sun is at the equator, but you're not at the equator. So the sun doesn't go directly above your head. It does this arc, it does a curve instead of a straight line. So the sun would never do a straight line at the North Pole. It would always go around you, and the sun would never do a straight line going above your head. The sun would always be turning at the horizon at the North Pole. So the sun never sets in Sweden and Scandinavia during the summer. It keeps going around the horizon, and it's never above the head or below the horizon. It's at the horizon. Sometimes it's twilight, where the sun is below the horizon, but even though it's below the horizon, you still get light because it's not a ball. Well, peep this out, guys. This is very interesting here. Look what happens when we go past the equator and we go to the South Pole. Boom. The South Pole is near the horizon. It's never above your zenith unless you go to the South Wall, which we're not allowed to go there. So no one ever takes pictures of the South Pole directly above your head except for the Army. And that South Pole going the opposite direction is just a reflection. This dome is reflective, and as that turns this way, like that, this goes the other direction.
So yeah, I think he does a pretty good job explaining it. I would probably critique it some, but so I have another video I didn't get to put in here where a guy actually just demonstrates it. He puts a dome, he puts the stars rotating or like lights rotating over top of him, and he shows that you'll actually get the exact opposite rotation towards the outside. So it's just an optical effect. He used 2 cameras to do it. Let me see here. And in fact, I'll go as far as to say no model can accurately explain the sky without acknowledging this because of this. Right? Like we have all of this phenomena that has to be explained. This has to be explained. And the globe cannot explain it. See, the globe uses the azimuthal grid of vision and then tosses it in a trash can and claims the Earth's a ball.